Today we are going to continue on with our exponential functions, but we're going to actually look at how those exponential functions apply in some real world situations. So sort of like exponential story problems. Okay, and those really come up when we have exponential growth or decay. And these are things that happen and relate to a lot of things in the world. So, I mean, the biggest one that you're seeing right now is COVID. Okay, viruses grow under exponential growth, but the population of rabbits, okay, how money accumulates in a savings account, interest. So lots of things out there that are going to have exponential growth and decay. Maybe you've heard of like carbon dating in your science classes. That's exponential decay. Okay. And when we're looking at anything with exponential growth or decay, sort of like we have right, y equals mx plus b, that for linear functions, and we had some things for vertex form, okay, we have a similar idea with exponentials, right? So when we are talking about a story problem of growth or decay, this is our general format. Y equals a, and then in parentheses, 1 plus or minus r, all to the x, where this value inside the parentheses here is our b value, right? Yesterday we said it was y equals a and then b to the x. That b value is going to be determined by taking 1 plus or minus a value. Okay, now we will use the addition sign if we want something to grow, right? Which makes sense. Something growing gets larger, so that's addition. We will use the subtraction sign if it is something that is decaying or getting smaller. The a value that we see in front of the parentheses is always sort of our starting value. Okay, it's the initial amount depending on what the problem is dealing with. And our R is going to be our rate in decimal form. So a rate is a percent most of the time. Okay, and we want that to be in decimal form. Okay. So when we are looking at actually writing an equation, this is the information that we'll need. So if we look at one in particular, okay, Jose opens a bank account and puts $1,200 in it. It earns 4% interest each month. Now I'm going to be really honest with you, that's not a realistic number to earn. However, when you do put money into certain accounts, they do earn interest. Okay, and so leaving money or some different things that you can do with different things with a bank will cause you to earn interest. I just simplified it into something that might make a little bit more sense for you. Okay, it's earning money. So if it's earning money, that means it's exponential growth. It's getting larger. So the formula that we want to use, right, here's exactly what we have, except we've just put in the addition sign because we said we would use an addition sign when we're talking about growth. So if we want to write an equation that represents this, y equals, our a value is going to be the initial amount. Well, the initial amount that Jose put in was $1,200. Okay, then we'll put a parenthesis, 1 plus. The rate is 4%. Now, remember, if we're turning a percent into a decimal, we need to move the decimal point 2 places to the left. This is something you absolutely should know at this point. You can also remember that it's 4 over 100 and divide that out. Or if you're absolutely desperate in your calculator, 4, there's a percent sign right above this open parenthesis. So if you do second percent, it will turn it into a decimal for you as well. So 4% is 0.04 all to the x. Now inside the parentheses, that's something that we can simplify, right? We can do 1 plus 0.04. So we'll say 1,200 and then 1.04 all to the x, right? 1.04 is just 1 plus 0.04. So my equation is y equals 1,200 times 1.04 all to the x. Now, let's make a table to represent the amount in the account for the first 5 months. This will be no different than just the tables we made yesterday when we were wanting to graph. So if we make a table, we just want to know the first 5 months. So I guess it determines, I didn't do a super clear job, right? 0 months might be the months where he first enters the value. But so 1, 2, 3, 4, let's maybe do the 5th month after it. Doesn't really matter. I want to make sure you understand the concept of that. If we want to know, we'll just plug this value in for x. And again, this is where a calculator will be handy. So we'll do 1200, 1.04. Now your up caret button, right, is sort of diagonal to 7. It's these two sides of a triangle. And we'll put in 1. So we get 1248. Okay, now we want to know after 2 months. 1297.92. Now we want to know after 3 months. Now, we're talking about money, so we're not going to have any more than 2 decimal points, so we always want to round to the nearest cent. So let's see, 1349.84. And unfortunately, if this was really a bank, I don't even think they'd round it up. They'd probably truncate, but we're not actually a bank, so we're going to stick to math rules. Let's do 1403.83, and then we can do 5. Okay, and the idea is just that we can see how this grows over time. Now, is it a reality that you're going to put $1,200 in a bank account and 5 months later have an extra $259.98? Well, no. Okay, but there are different things that you can put money into, and over time it grows. And yeah, if you give it enough time, this will really start to take off and get larger and larger. So let's say we let it set for 3 years. Now, the key here is that our value was per month. So if we want to plug in something that's of a different type of label, we need to make sure we adjust. So if we want 3 years from now, that would really be 36 months from now. So we'll want to use this same equation, but plug in an x value of 36. Okay, so I can just use that one I had before, and I'm going to go over and change that into 36. And 4924.72. Okay, so as long as you can get the equation from the original information, you're pretty much home free. Now, the small piece that we might have to consider is that a percent isn't always given directly to us. We might have to consider what it means in terms of the words that we read. So each year, the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? So we need to write an equation to represent that. If we want to know how many are left after 5 rounds, let's consider an equation here to represent that. So if we start out, we should understand that they are eliminated. If they are eliminated, it's getting smaller, and so we want to use a subtraction sign. Okay, so y equals our starting amount. Play starts with 128 participants. Parenthesis 1 minus. Now, we don't see a percent in here anywhere, but it does tell us half of the players are eliminated. And hopefully this is also something we should know, that half as a percent is 50%, right? A quarter as a percent is 25%. That's something we should know. So 50% as a decimal will be 0.5. And again, inside the parentheses, that's math we can do. So we'll say y equals 128. And then 1 minus 0.5 is just 0.5. So it looks like I'm just bringing that number down and forgetting the 1, but I'm not. I'm really doing that math. Okay, so if we want to make a table to show these rounds, right, we could do that. And we could evaluate just by plugging this into a calculator. Now, this is one realistically, right, we could probably just do in our head, but just to make sure, right? So after 1 round, there'd be 64 players left. After 2 rounds, there'd be 32 players left, right? If we're going down by half, hopefully our next one's gonna be 16. Okay, so if we wanna know after 5 rounds, right, we could just plug in 5, and there will be 4 players left.